Number 8, you're asked to transform the following polar equations, meaning that they're written in terms of r and sine and cosine and theta, into equations in rectangular coordinates x and y. Then we're asked to write the equation in standard form and state the center and the radius. So if you look at number 8a, you're given this polar equation. If you were to graph this in your calculator, exactly how it's written in polar form, you would see that it's a circle. So really our job here is to convert this to its circle standard equation in rectangular coordinates, so x and y. Now when you look at this, you have an r, which is polar, and then sine theta, which is also polar. But in order to use the formulas, we kind of need them written in a different way. So if you look at your formula sheet, you have these three equations. Now again, we're given r's and sines and theta, so really what we're going to be looking for is to find forms of these. So we're looking to see if we can get an r cosine theta or an r sine theta. And really for r, you can use the square root of x squared plus y squared, but really it's a little bit nicer and it makes the simplifying better if you can get r squared, which then if you can get an r squared you can just replace with x squared plus y squared because they are equivalent. So really for these you're just using substitution. Likewise up here, if we have an r sine theta, we can replace it with just a y. So if we go back and look at what we have, we almost have those things. On the left side, we have this r. It'd be a lot better if it were r squared, because then we could use x squared plus y squared. On the right, we have sine of theta, which sine of theta is no good unless there's an r in front of it. So if you look, both sides really could use an additional r. So you're allowed to multiply both sides by whatever you want. We're going to choose to multiply both sides by r, because that gives us an r squared, and then a negative 14r sine theta on the right. From here we can use substitution. R squared you can replace with x squared plus y squared, and then r sine theta we can replace with y. Now we're supposed to write this in standard form, so that means get everything to one side first. So x squared plus y squared plus 14y is equal to 0. And then we're going to have to complete the square. We're going to have to complete the square on the y term so that we know what the coordinate for the center is. We don't have to complete the square on the x squared term because there's no single x to the first term to go with it. So you take this plus box is equal to 0 plus box. Remember, the number that's going to go inside the box is half of that middle term. Pay attention to the sign. In this case it's a positive 7, so positive 7 on the other side. So your standard form for that circle is x squared plus, in parentheses, y plus 7, the quantity squared, is equal to 49. So that's our standard form. From this we can pick out our center. There's no number with the x squared term, so that means that the coordinate for your center for x is 0. And then with the y, there's a plus 7, so that changes sign, so the center is 0, negative 7. And the radius, you take the square root of this guy here. So the square root of 49 is just 7. Again, if you graph that, if you graph the original r equals negative 14 sine theta in your polar graph, it should correspond to these equations in this information.
Made with Doodlecast Pro.